This is Dr. Abid. So this is the second video in the series why design verification is within as a separate profession. And we discussed that there are 10 good reasons, and we have discussed 3 reasons in the last video. The one was we need to know have some mechanism to generate random stimulus, and then we should write automated checkers because verifying things on the waveform is simply not possible for complex ICs. And then we should have some mechanisms to drive signals at a higher abstraction layer instead of playing with the signals at the low level to apply different test vectors. So this is something we discussed in the last video. So we have a design under test over here, which is layer 0, and then we are applying the stimulus using driver low level signals, but we want to take the level high in layer 2, where we actually applying the transactions as write memory or read memory. So we're just specifying address and data address, and instead of worrying about the low level signal. So the low level mechanism is being handled by the driver itself. So this is the layer test bench is another important way that is really important in design verification. Now coming to the fourth one. So let's say you are actually designing a memory module in RTL, and you have to specify the port list here for all the signals. Okay, so clock, read, write, address, data, and then once you instantiate it into test bench, we have to do the we have to connect all the ports. Okay, and then so right now we are testing the memory, but let's say in the design actually you have to connect this memory into the CPU, and could be some other interfaces as well. So you have to perform all these connections. Okay, and this is really cumbersome. It just make your code lengthy as well, and it's really hard to track things. Okay, so what we do actually is to group these signals together using an interface. Okay, so let me just tell you what I mean by this. So let's say this is driver is actually here we are applying the signals to the dot over here. So these are the group of signals. You can just apply them as an interface, group these signals as an interface. So what does that mean? So let's say we have a test bench. Let me just take another normal pen. So this is my test bench. Okay, so what I will do that I will just declare an interface just like we declare a module. Put all the signals at end interface, and then generate an instance of the this interface over here. And then once we specifying this is your design, and when we are running the module memory, so we just put a port list, we just put an interface over here. Okay, so once we are actually inside the module, what we can do, we actually have to go to the, let's say, positive clock. So instead of referring to the clock, so we will say my interface dot clock. Okay, so this is how actually you can access the signals inside the board, but outside we just have one group of signals interface. And likewise you can specify over here that how you are going to connect. Is instantiating the interface over here, and then we are actually connecting the interface with the port list. Okay, so this is to simplify things. And like the last so we will talk about all these things in detail, but I'm just giving you the motivation that why all these topics are really important. And the fifth most important thing is the reusability, and I really want to spend some time on this. So what do I mean by this? And we need to know the object-oriented programming concepts over here. and there's an important topic of verification IPs, but the reusability is really important. So what do we mean by reusability? So I think we have already talked about this before. So let's say we have the design under test. This is the memory module, and we have instantiated it, and this is at layer 0. So typically this is called signals layer. So everything is the actual signals, wires, so clock, read, write, address, and whatever. So these all are the signals. And then we talk about this thing here, that we actually generate a driver over here, and this driver is actually doing, it's a class. So it's actually written as a software, and then it is converting this into class to signals. And then we talk about, in the previous one, we talk about the sequencer itself, which is actually generating high level transactions. Okay, so, and then we have, on top of this, we have the generator, which is actually generating multiple of transactions. Let's say write, read, write after read after write. So this is the self-contained environment. So there's a generator which is generating multiple transactions, then the sequencer is taking one transaction at a time and then sending it to the driver, and then driver is actually converting this into low level signals. So all these are actually classes. So there is a class to class communication as well, so we will see inter-process communication later. And then we have this class and signals at the lower layer. Okay, and as we apply the stimulus from here, we apply the stimulus in this direction, and then we actually getting the response in this direction. So during the response time, we have this monitor which is actually monitoring the response, just like we are doing the read transaction, and then the data that will be received is the monitor. And then from the monitor we just go to the scoreboard, which is actually your automated checker, which is just checking that what the data is written is actually same data that you are reading. So the whole this thing is actually contained in an environment, all these modules, and this is called VIP, verification IP. So you see here, this dot is outside of this one, and then we have a the test here as well, which is a tester is typically provided with the environment, so which we can use to apply different tests. And then both the this test and verification, along with the data, then are contained in a top module. Okay, so this is what it is I meant by this. So we have the dot separate, and then we have a verification IP, and so I can really reuse this verification IP for multiple different things. So we will talk about this in much detail, but for now you just have to that there is just like an IP for you design a UART core or a CPU core or RISC-V core, which is called IP. There is similar, we have a verification IP as well. So let's say you have already written this verification environment to test a UART or an SPI, you can call it a VIP, and you can really sell it as well. Okay, so far we have discussed these 5 good reasons. So I think we can stop it over here, otherwise the video will be quite long. So let's just discuss the remaining 5 reasons in the next video.